Okay, solving systems of linear equations. I think you guys have done this before, maybe, but we're going to do it again. And if you haven't, then this is the first time. Okay, we're not going to fill out this vocabulary right now. We might do it in class. We'll see. Okay, skipping that. So here's just the different types of solutions you can get. So if you get no solution, that means that the two lines never cross. Since these are linear equations, they're parallel, or they're not parallel, they're lines. So if it's no solutions, that means the lines are parallel, they never cross. If it's one solution, that means they cross one time. And if it's infinitely many solutions, that means it's the same exact line. Okay? Those are just the different types of solutions we can get. So there's two ways to solve these. We can solve it by substitution or by elimination. I'm going to show you guys both ways. So let's start this one by solving by substitution. So we need to decide what variable we're going to solve for. I always look at the equation. So I have x plus 3y equals 5 and negative 2x minus 4y equals negative 5. The first equation has an x that's all by itself. So I'm just going to solve that first equation for x. So I get x equals negative 3y plus 5 because I just subtracted that 3y over. Okay, so I was working with the first equation. I solved it for x. Now I'm going to plug that x in for the second equation. So I'm going to plug negative 3y plus 5 in for the x on the second equation. So that becomes negative 2 times negative 3y plus 5 minus 4y equals negative 5. And then I'm just going to go through and I'm going to solve this for y. So I get 6y minus 10 minus 4y equals negative 5, which is 2y minus 10 equals negative 5. Add the 10 over, you get 2y equals 5. Divide by 2, you get y equals 5 halves. So I've solved for y. I need to go back and I need to solve for x. So I'm going to plug that y in for the equation that I first solved for x. So I'm going to have x equals negative 3 times 5 over 2 plus 5. We multiply that out. That's x equals negative 15 halves plus 5. 5 is the same thing as 10 over 2. So that's x equals negative 5 halves. Okay, then you just write your answer as an ordered pair. So it's negative 5 halves because x always comes first, and then 5 halves. If it's not x and y, say it's like L and M, you always just put it in alphabetical order. So like L comes before M, I think. But yeah, so you always just put it in alphabetical order if it's not X and Y. Okay? Let's do another one. Or let's look at this word problem. So an online music company offers 15 downloads for $19.75 and 40 downloads for $43.50. Each price includes the same one-time registration fee. We need to find the cost of each download and the registration fee. So I'm just going to write this out. 15 downloads and registration fee is $19.75, and 40 downloads and registration fee is $43.50. So if I change those to sentences, first I'm going to let D equal downloads, and I'm going to let R equal registration fee. So that's going to be 15D, because 15 downloads, plus the registration fee, so plus R, equals $19.75. And then 40D, because 40 downloads plus the registration fee equals $43.50. Okay, so I have my two equations, I have two variables, so I can solve this. I'm going to solve the first equation for R. So I get R equals negative 15D plus 1975. And I'm going to plug that into the second equation. So I get 40D plus negative 15D plus 1975 equals 4350, which is 25D plus 1975 equals 4350. Subtract the 1975 over, you get 25D equals 2375. Divide by 25, and you get D equals 95 cents, or 0.95. So that means each download is 95 cents. Okay? We need to go back and figure out what the registration fee is. So I'm going to plug D back into that equation up there. So I have R equals negative 15 times 95 cents plus 1975. Multiply that out, you get R equals negative 1425 plus 1975. which is R equals $5.50. So the registration fee is $5.50. Each download is 95 cents. Okay? So that was the substitution method. Now we're going to use the elimination method. So the first thing, you need to make sure these are in standard form. So it's like ax plus by equals c. And then we need to decide, what variable am I going to eliminate? If I'm going to add these together, I need to find opposites for the variable. So like here in example 3, we have 8y and we have negative 8y. Those are opposites. So when we add these together, they're going to cancel. And I'm left with negative 2x plus 5x equals 3x. Negative 8 plus 20 equals 12. And then I'm just going to solve for x. So I'm going to divide by 3, and you get x equals positive 4. Now, I'm going to go back, and I'm going to plug x into either one of the equations. It doesn't matter. Sorry, I have weird hiccups right now. It doesn't matter which one you plug it into. So let's just plug it into the top one. So negative 2 times 4 plus 8y equals negative 8. Multiply that out. You get negative 8 plus 8y equals negative 8. Add the 8 over. You get 8y equals 0, which means y equals 0. And you can always plug those back in to these equations and make sure they work. And then the last step is to just write it as a coordinate point. So that's 4, 0, because x comes before y. Okay, let's do another one. So here, we don't have a very obvious pair. We don't know, there's not one that's just going to cancel if we just add these together right at the beginning. So I need to decide which variable to get rid of. Do I want to get rid of my x's or do I want to get rid of my y's? I'm going to decide to get rid of my x's, okay? So I have 3x on top. I have to think, what do I have to add to 3x so that it equals 0? So 3x plus what equals 0? It's negative 3x, because 3x plus negative 3x equals 0. And I have an x right there, so it's x times what equals negative 3x, or what do I have to multiply that bottom equation by to make that so it's a negative 3x? Well, it's negative 3. So I'm going to go and I'm going to multiply the bottom equation by negative 3. When you multiply that out, you get negative 3x minus 6y equals negative 15. Now I'm going to add those two equations. The 3x's cancel. I'm going to draw on this real quick. So these cancel, those are gone. And then negative y minus 6y is negative 7y. 8 minus 15 is negative 7. Then you just solve for y, divide by negative 7, you get y equals 1. Now that I have y, I need to plug that back into one of the two equations above. It doesn't matter, I'm just going to choose the first one. So I have 3x minus 1 equals 8. So that's 3x equals 9 if I add the 1 over. So x equals 3. Then I'm just going to write this as a point. So that's 3, 1. And you're done. Okay? Let's do these last two. So in example A, I'm just going to decide to get rid of my x's because there's not really an obvious one to get rid of. So when there's not an obvious one, you just kind of have to pick. I'm going to multiply the top equation by 5, and I'm going to multiply the bottom equation by negative 3. So that top equation, I'll end up with a 15x, and in the bottom equation, I'll end up with a negative 15x. So when I multiply that out, I get 15x plus 35y equals 75, and negative 15x minus 6y equals 12. Now I'm going to add those. Those cancel. I get 35y minus 6y equals 29y, and 75 plus 12 equals 87. Divide by 29. 87 divided by 29 is 3. Now I'm going to just plug that back into one of my two equations. I just picked the top one because it's the easiest one. Or it's not the easiest one, it's just when there's not really an obvious one to pick, I always pick the top one. Okay, so then you just solve this. 3x plus 21 equals 15. Subtract the 21. 3x equals negative 6, so x equals negative 2. Your answer here is negative 2, 3. And we're done. Okay, we're not going to do B. We need to do these two real quick also. So I'm going to decide to get rid of my x's again. And I'm going to multiply the top equation by 2, so that becomes a negative 2x. Okay, so if I multiply that top equation by 2, I end up with negative 2x plus 2y equals negative 4. Then I'm going to add the two equations. So negative 2x plus 2x is gone. 2y minus y, or minus 2y, is gone also. So I'm left with 0 on the left side of my equation, and 0 equals negative 4. But 0 does not equal negative 4. 0 will never equal negative 4. So that is not correct, and there's no solution. So if you ever end up with an answer that, like, 0 equals 5, or 5 equals negative something, and it's not true, then it's no solution. Okay? Let's look at B. So I'm going to multiply the top equation by negative 3, so I can get that to be a negative 12. So that becomes negative 12x minus 3y equals negative 18. Now I'm just going to add these. Negative 12x plus 12x is gone. Negative 3y plus 3y is gone. Negative 18 plus 18 is also gone. So I'm just left with 0 equals 0, which is true, so that means there's infinitely many solutions. So if you end up with 0 equals 0, it's infinitely many. If you end up with 0 equals some number, it's no solution because 0 does not equal some number. 0 will always equal 0 for as long as we live. Okay? Remember to take the quiz, and I will see you guys when I see you.